Sometimes you need to make measurements where using cabled sensors is a problem. For example, protecting cables by running them through conduit or burying them in trenches is time-consuming, labor-intensive, and sometimes not even possible. Or local fire codes may preclude the use of certain types of sensor cable inside of buildings. In some applications, measurements need to be made at distances where long cables decrease the quality of the measurement or are too expensive. There are also times when you need to add sensors, but the data logger does not have enough available channels. The solution? A Campbell wireless sensor network. A wireless network provides a reliable, low-maintenance, low-power method for making measurements in applications where cabled sensors are impractical or otherwise undesirable. Hello, I'm Colin Daly with Campbell Scientific in Logan, Utah. In this video, I will cover the basics of a Campbell wireless sensor network. I'll show you the hardware components and some of the software that you'll use. A wireless sensor network consists of a wireless base station and one or more wireless sensors. The base station serves as the gateway to the network, communicating with a Campbell Scientific data logger and all of the wireless sensors in the network. You'll also need a data logger in your network. A CR800 series, CR1000, or a CR3000 would work fine. To set up a wireless sensor network, first the base station and the wireless sensors are configured using software. Here's how it works. The data logger is programmed in CR Basic to communicate with the CWB100 base. The sensors are then synchronized to measure at the top of the data logger's scan interval. The base station pulls all of the sensors and stores the collected data early enough that it transfers the data as soon as the data logger requests it. Doing this minimizes the amount of time that the data logger needs to wait for a response from the network through the base station. At the start of each polling interval, the data logger polls the base station, and the sensor values are then transferred to the data logger for storage. This provides for the fastest data transfer and uses the lowest power available. Now let's take a more detailed look at each of the components. This is the CWB100 master radio. We call it the base station in the wireless network. It pulls up to 50 wireless sensors and passes the data to the data logger when requested. Communication with the data logger happens over a single control port. It works by using a frequency hopping spread spectrum radio to give it a longer range with less interference. The radio can communicate with sensors over 300 meters in optimal line of sight conditions. Now I'll introduce the sensors. Currently, the family of wireless sensors consists of the CWS220, the CWS655, and the CWS900. The CWS220 infrared radiometer. It integrates Apogee's SI111 infrared sensor with a radio in one compact body. It is used to sense infrared radiation from surfaces to calculate the surface temperature without physical contact. This is the CWS655 soil water content sensor. This sensor has rods that insert into the ground that measure soil water content, electrical conductivity, and soil temperature. The CWS655 wireless sensors can be spread out over a field and transmit data to the base station in a secure location away from the field. The CWS900 is particularly exciting because of the broad spectrum of measurements it can bring into the wireless sensor networks. It is a radio with a sealed connector that can be attached to a variety of sensors. It can measure analog voltage and frequency. It can count pulses and supply excitation voltage, making it compatible with many types of low-power sensors. Because of the low-power design of the system, each one of the sensors is powered by only 2 AA batteries. The batteries can last up to a year with a 15-minute sensor pull. If solar is your thing, there's also a mini solar power option that keeps batteries charged with only 3 hours of light per day. Also, every wireless sensor can act as a relay or a repeater for other wireless sensors in the network. This means that data can be relayed up to 3 hops in a network. Here's how to get the wireless sensor network configured. First, you'll need to configure the wireless sensors. To do this, you'll need an A205 connected to the USB port of your computer and the other end to the wireless sensor. Make sure that your wireless sensor has been powered down for at least 15 seconds before connecting the A205. The same A205 can be used to configure all the wireless sensors in your network now and as your network grows. There are a few software tools that you may use. It's your choice. You can use the Network Planner, the Wireless Sensor Planner, or Device Configuration Utility. If you have LoggerNet 4.1 or later, you'll use the Network Planner to set up and configure your wireless sensor network. Those with earlier versions of LoggerNet or PC400 we'll use the wireless sensor planner which comes with your CWB100, or you can download it from our website. Device Configuration Utility 1.17 and later also supports wireless sensors. PC200W does not support the wireless sensor networks. You'll need either PC400 or LoggerNet. We'll talk more about actually using the software in a later tutorial. Freeing sensors from the location of the data logger significantly expands the possibilities in many applications, while at the same time simplifying installation and reducing costs. For example, networks of rain gauges can be scattered through a watershed as needed. Large numbers of temperature and soil moisture sensors can be installed throughout working fields. You could probably think of other scenarios where it would be useful to place a sensor several hundred meters away from the data logger. Here at Campbell Scientific, we're excited about the potential that these new wireless products hold. They are compact, use little power, are rugged, and weather sealed. The sensor modules are each leak tested before shipping, and in real-world testing they have withstood wind, rain, snow, and hail. Even when installed 1 meter below the canopy of a mature cornfield, they were able to transmit up to 150 meters. The possibilities are very encouraging. Please contact Campbell Scientific to discuss your application and for answers about setting up your network.